Ma'am, can you repeat?
Yes. Valency. First write valency and underline it and write down the combining capacity. The combining capacity of an atom to give, comma, lose, to give or to uh, gain, to give, comma, gain or share, to give or gain or share electrons to achieve the octet state, to achieve the octet state.
Ma'am, can you spell the octet?
Octet, OCTET.
Ma'am, OCT.
OCTATE. Sorry. OCTATE. Octet state. So what is this octet state? Octet state is nothing but gaining of the octet means 8. So when these atoms are attaining the 8 electrons in the outermost shell, in the valency shell is nothing but the outermost shell of the atoms. So either it might be sodium or it might be fluorine or it might be any element. The elements, they have their shells, isn't it? They have shells. So these shells are being named as, what are the names of the shells? Can anyone just tell me?
Ma'am, KLMN.
Yes, KLMN. Even OP also depends on the number of electrons they are being arranged inside these shells. So these different types of shells, in these different types of shells, the electrons will be moving around. Like here in this, for example, if we see, this is a sodium atom. So in this sodium atom, how many shells are there? 3 are there. So in these 3 shells, the electrons are being arranged. So what is the atomic number of sodium?
11, ma'am.
Atomic number of sodium is 11. So how many number of protons and electrons will be there in sodium?
Ma'am, 11.
Yes, so number of protons will be 11, number of electrons will be 11.
11.
So here how it is being arranged. So it's been arranged like this, 2 plus 8 plus 1, isn't it? If you count it, it will be 11. So in the first shell, in the K shell, 2 electrons are being kept here. So here you can see the 2 electrons here and here, 2 electrons in the first shell. 2 electrons are being arranged. So this is a stable shell. And now in the second shell, how many are there? 8 electrons are there. Here, if you count this, 8 electrons are being arranged here. So they'll be moving, going on moving. They won't stop. And the last shell, only 1 electron is there. So is it stable? No. To attain the stability, what it has to do, it has to follow the octet rule. Octet rule is nothing but gaining 8 electrons. 8 electrons must be there in the outermost shell. Then it will gain the stability. Otherwise it will be unstable. It always wants to gain electron to become stable. So sodium need more, how many electrons to gain the octet rule, to follow the octet rule to become stable? It needs 7 more electrons, isn't it? To follow the octet rule. Octet rule is nothing but, octet is 8 number. To become
Yeah, ma'am.
8, then it will be stable. So now it has only 1 electron in the outermost shell. What it will do, it will think of gaining 7 more. So can it gain 7 more electrons? No, it need more energy. to gain 7 electrons. So it's easy to lose this one, to get rid of this one electron, isn't it? It's easy. Rather than gaining 7 electrons, it's easy to lose 1 electron. So it will lose 1 electron. So after losing, it will become 2 plus 8. Now it's becoming stable. Now the charge will be plus 1 because it has lost 1 electron, isn't it? You'll represent it like plus 1. It has lost 1 electron. So this is in the case of sodium.
Ma'am,
Yes?
ma'am, why it lost one electron, ma'am? Because
To
it is
attain the stability. To follow the
okay, ma'am.
octet rule. What is
Okay, okay.
octet rule? To gain 8 electrons in the outermost shell. So here in
Huh,
the
ma'am.
outermost shell, it is having 8 electrons, isn't it?
Yeah, ma'am. In that first one, it have 9.
Yes.
So okay, ma'am.
Yeah. So whenever an atom wants to combine with another atom, it needs to lose or gain electrons, isn't it? Whenever an atom
Yeah.
wants to gain or lose electrons, it needs what it has to do. It needs to, if it wants to combine, suppose we want to make NaCl. So this sodium is combining with chlorine, isn't it? NaCl. So what it has to do, it has to either gain electron, it has to either lose electrons, or it has to share. So we'll see one by one in each case what it is doing. In NaCl, what it is doing. In other compounds, in formation of other compounds also, what it is doing, how it is attaining the stability. To see this, first we have to understand this, what and how the electrons are being arranged in this valency shells, how to write the electronic configuration. After that, we'll do these. In the page number 38, you're having some combinations of different compounds, isn't it? So after knowing about all these, how to write the electrons, how to adjust the electrons in the valency shell, how to write the electronic configuration, then we'll go on with the with this formation of the simple compounds. Okay, first we'll understand this one. So to understand this, we must know the atomic number and then how many electrons are accommodated inside it. We must know, we must have a clear idea about that. So that's why I asked you to write the periodic table. So every one of you have the periodic table with you?
Yes, ma'am.
Yeah, ma'am.
Okay, if at any moment, if you're not understanding properly, then you can you can even message me, or you can even stop me in the middle and ask me the doubts if you have any. Okay, just one second. Have you understood this clearly? Or if you have any doubt, then I'll explain it once again.
No, ma'am.
Understood, ma'am.
Yeah,
Okay.
ma'am.
So the valency is the combining capacity of an element. I'm repeating once again, the combining capacity of an element or an atom to gain or lose or share electron. It's called as its valency. Okay, children? So, but in this case, they need to follow the octet rule. So what is this octet rule? Octet is nothing but gaining 8 electrons. 8 electrons must be there in the valency shell. So then only that particular atom, that particular element will follow the octet rule. So this octet rule was given by Bohr, the scientist Bohr. Okay, so let us first know what this octet rule is. So octet means 8, as we have already discussed. Any atom which has 8 electrons in its outermost shell, then it will gain the stability. Okay, when it is having 8 electrons, then it will be stable. It will gain stability. If it is not stable, then it will try to gain or lose electrons in order to become stable. When it will lose electrons, like in this case, in the sodium, like how we have seen now, the example, in sodium atom, only 1 electron is there in the outermost shell. Then naturally it tries to lose that 1 electron to attain the stability, because in the second shell, second orbit, it is having 8 electrons, isn't it? Count it in the second shell. How many are there in the sodium atom?
8, ma'am.
8. So it tries to lose that one electron to attain the stability. Stability in the sense 8 electrons are there in the second shell. Naturally, it will follow the octet rule. Okay, is it clear?
Yeah, ma'am.
Yeah, ma'am.
It will gain the stability, it will follow the octet rule, and then it will become inert. Inert in the sense, following the octet rule, having 8 electrons in the outermost shell, it will become very safe now. Now nothing will disturb it. Nothing will come and disturb it. If you're trying to disturb it because there is no chance of giving or gaining electron, then it can share the electrons. Especially if we see in the case of helium, the atomic number is 2. Isn't it? Accommodating, I'll just draw it here. Just one second, I'll draw it for you. So now, in the case of helium, what happens? So here, if we draw, this is the nucleus, and naturally it is having the protons in the middle, and this is a shell for helium, and it is having 2 electrons. So having 2 electrons in the first shell, then what is the atomic number for this, children? What is the atomic number for helium?
2, ma'am.
Sorry?
2, ma'am.
Yes, it is 2. So here, just one second. Oh, I'll just share it. She's having a problem last year. She's joining again and again. Okay, so here in the case of helium, its atomic number is 2, and the number of electrons. How many electrons you can see here?
Ma'am, 2. 2.
2 electrons. So is it stable?
Yeah, ma'am.
It has any chance of giving an electron to others?
No,
No,
ma'am.
because
No.
it is having
Yes, ma'am.
2 electrons. So it is, especially in this case, it cannot accommodate 8 electrons. It is not possible in the case of helium. There is no chance. So here what happens in the case of helium especially, it has an assumption. It will follow another rule. It won't follow now the octet rule because it can't accommodate 8 electrons here. It has 2 electrons and it is stable. Now it follows another rule. What is that rule? That rule is duplet rule. Duplet means 2. It follows duplet rule. So now we'll see what this electronic configuration is and how to fill all these orbital, and how we are filling, how these electrons are being arranged here. We'll see now. I hope you all know this already, but I'm explaining it once again to make it more clear to you. Is it fine to everyone? Yes? Or you want me to rush on with the lesson? Shall I explain everything? Yes, you can't hear my voice. You want me to explain about the electronic configurations and how the valencies are being arranged, how the electrons are being arranged inside a valency shell, and how the orbitals are being, how the electrons are being arranged inside these orbitals. So shall I explain it or shall I skip it?
Explain, ma'am.
Ma'am, excuse me, ma'am.
Yes.
Ma'am, can you explain the last one, ma'am? The orbit, like the valency one. Because
Yeah.
I entered the
Okay.
class again, ma'am. I missed
Okay.
it.
Yes. I am explaining it once again.
Okay, ma'am. Thank you, ma'am.
Okay. So now, in the case of electronic configuration, how to fill it, there is a nucleus. Oh, sorry. So for an atom, there is a nucleus in the middle, isn't it? And what is
Yeah,
the
ma'am.
charge to that nucleus? What is the charge here? What is having along with the nucleus? What will be present
Positive, ma'am.
inside? Positive charge. Protons will be there in the middle of the nucleus. Protons will be there. And where are the electrons? Electrons will be revolving around this nucleus, isn't it? I think you've already learned it. Sorry, my drawing is a little bit very poor, especially in this on this whiteboard. I can't be able to draw it properly. I hope that's fine to you. Can you understand it?
Yeah, ma'am.
Yeah, ma'am.
Okay. Or I'll just draw it very neatly. Just 1 second. Again, it went wrong. Okay, that's fine. So here, there are circular orbits in which the electrons will be revolving. When these electrons are revolving here, the electrons will be revolving around this nucleus. So the number depends on the atom which you are taking. The number, it depends. The count of the number of electrons will depend on the atom which you are taking. Either it might be sodium or chlorine, fluorine, whichever atom you are taking. This number of electrons will vary depending on their electrons which are present depending upon their atom, the atomic number which is being given to that particular atom. So just now we have seen for sodium atom. What is the atomic number for sodium?
11, ma'am.
It's 11. So we'll decide how many electrons will be there inside this sodium atom. I'll erase it. So now for sodium, how you will write, what number you will be giving here? Yes, how you will draw. This is the nucleus. It has the positive charge, and you're going to write for sodium atom. And now tell me how many electrons you will accommodate in the first shell. So this is the first orbit, and this is the second orbit. And now tell me how many electrons you'll accommodate in this first.
Ma'am, 1.
First.
2, ma'am.
Okay. Okay, I'll write it here. 2. Its electronic configuration will be 2, 8, and 1. And now tell me how many electrons you will accommodate accordingly. So in the first shell we have accommodate with 2. And now in the second shell we'll accommodate with
Ma'am,
8.
8.
Yes, so here we'll accommodate 8 electrons. Okay. Yes. So 8. So second orbit is filled now. First orbit is also filled now. And the left is the third orbit. So how many electrons will be there in the
1.
third orbit? 1. Yes. So this is the 1. It's alone now. So in the outermost shell, it is having only 1 electron. So what it will do now? Is it stable or it is unstable? Is it
Ma'am,
following the
unstable.
octet rule? Is it following the
Unstable.
octet rule?
No, ma'am.
No, it's not following the octet rule. To follow the octet rule, what it has to do now?
Ma'am, it should go for another one.
Ma'am,
Means-
to gain or to lose?
Yeah,
Yeah.
to lose it.
It must gain or it must lose the electron.
Lose, ma'am.
What it will do now? Will it gain 7 electrons? Will it gain 7 electrons?
No, ma'am, it will
Plus
lose.
to become 8? Is
Ma'am,
it
it will
possible?
lose, ma'am. No, ma'am, it will lose.
Lose 1 electron. Okay? It will, sorry, I have to write like this. It will lose 1 electron. So it's easy to lose 1 electron instead of gaining 7 electrons because it needs more energy to gain 7 electrons from outside. It's easy to lose 1 electron and become stable. Now when it loses 1 electron, what happens? Now it attains, it follows the octet rule. Just 1 second. Now it is losing this 1 electron, and now it will become, it is having,
8 electrons.
yes, it is having 8 electrons, and now it is following octet rule.
Octet.
Yes. And now what will be the charge for this?
+1.
Plus
Plus one,
1.
ma'am.
Yes, good. Plus 1. So sodium will be with plus 1. If it loses 1 electron. After losing 1 electron, it is having the represented by charge plus 1. Okay, now it's clear
Positive.
to you?
Yeah, ma'am.
Okay, that's fine. And now we were discussing about, we have already discussed about the helium, which is inert gas. It follows which rule? Helium follows which rule? Its atomic number is
2, ma'am.
2. So it follows which rule?
2, ma'am. Ma'am, it is a diatomic.
Yes. So can it follow the octet rule? Can it accommodate 8 electrons?
No,
No,
ma'am.
ma'am.
No.
No, ma'am.
Then it has a special rule to follow. That is duplet rule. Okay? Helium follows duplet rule because it cannot accommodate 8 electrons. Okay, now the presence of protons and because it is having positive charge now, the nucleus is having positive charge in the middle, isn't it? Because of presence of protons. There are circular orbits as we have seen for sodium atom, isn't it? So we can fill the orbital. We can fill the orbital by using this rule, which is 2n square rule. We can fill the orbitals by using this 2n square rule, where this n, it represents number of, you can write it down, number of orbits or shells. Okay? N means n represents the number of orbits or shells. So it has to follow 2n square rule. So we'll see now the valency shell is the last shell in which the electrons enters, where the electron, if any electron, if something is giving the electron, then where the electron must enter first? Will it enter the first shell or the second shell or the third shell? So here is an atom. So this is the first shell and this is the second shell, and suppose this is the last shell, the third shell. It's having, suppose this is a last one. Its electrons are being filled completely in the second shell also, and it's having the empty place here in the outer shell. So where the electron will enter first? The electron will enter the last shell first, isn't it? This here in this area, the last shell, the electron will enter the last shell first to pair with any, if it is having 7 electrons, suppose. In the last shell, if it is having 7 electrons in the last shell, then it needs one more. It needs one more to attain the stability and to gain 8 electrons. So where this 1 electron needs to accommodate, where there is deficiency in the last shell. I'll just draw it neatly so that you can understand it quickly.
Ma'am, I got a question.
Yes.
Is there any like once you reach a certain number of electrons on the last shell,
Yes.
does it need to like round up the
Yeah, it will become
electrons
stable
or?
now. It will
I
become
know.
stable. Yeah.
I understand that part, but is there like a certain number where it'll round down or round up?
Yeah, I told na. It must follow the octet rule. 8. It must attain 8 electrons to attain the stability. It must gain
Yeah,
8.
ma'am, I know that, but like suddenly if it's like 3 electrons or 4 electrons, like does it round like go to? Does it add another 4 or minus 4 like that? That's my
No,
question.
no. I'm coming to that point. I'll explain you that point also. So in this case, the last number is to attain the electrons, or to gain or to lose. The number is only 3. They can either gain 3 electrons, or they can either lose 3 electrons, not more than that. Okay, is it clear? Okay, now, so it's possible for any electron to enter is only in the last shell. Okay, valency shell is the last shell in which the electron enters. Okay, so this is the first shell, this is the second shell, and this is the third shell. And now when it is the last shell is having, suppose 7 electrons, it is deficient with 1 electron. To attain the stability, it needs 1 more electron to gain the stability to become 8, isn't it? So where it will accommodate, either it will accommodate here in the first shell, or in the second shell, or in the third shell. Where is the deficiency? In the last shell. Yes, good. So what is this last shell known as? What is this last shell? The last shell in which the electron enters is known as?
Ma'am, K.
I'm not asking you the name of that. It is
Okay.
called as valency shell. It is called as the valency shell, wherein it will accommodate the electron. Okay. Sorry, there's a spelling mistake here. So this is the valency shell. So here in the first orbit, that is the K shell, there are maximum number of electrons. Now, is there any possibility to allow the electron to enter in the first shell, in the K shell? No. And there are already 2 electrons there, isn't it? It's already filled. There are 2 electrons and there is no space. That is why in the case of helium, it follows the rule of duplet. It is already filled. In the case of helium, we already have discussed. So now, what about the next shell? So in the next shell, so in the case of helium, in this next shell, now it follows the rule of 2n square. In the case of helium, if we talk about, when it is following this 2n rule, now we'll imply this 2n rule here. Okay, later on we'll discuss about this 2n rule. You want me to explain about this first?
Ma'am, 2 minutes are left.
Ma'am.
Yeah, ma'am.
Okay, okay, let us discuss it tomorrow again about this rule.
Yeah, ma'am.
Okay.
Yeah, ma'am.
So you've understood about this valency shell and the electronic configuration and how these electrons are being accommodated? Is it
Yeah,
clear
ma'am.
till now?
Yeah,
Oh,
ma'am.
okay, if any doubts, tomorrow we'll discuss a few more things with more examples. Okay,
Okay, ma'am.
Okay, ma'am. Thank you, ma'am.
do you have the class now?
Yes, ma'am.
Yeah, ma'am. Telugu.
Okay, just one second. So still the count is only 16. Only 16 members are there. Why it is decreasing from 24 to only 17 in this class?